Today we're going to talk about finances, exponential growth, and how we see that in the financial field. When you borrow money from a bank, you have to pay interest. If you put your money in an account at the bank, some type of savings account, then you earn interest. So we're looking at different kinds of interest. We're going to look at what's called simple interest first, which an example here, if a parent loaned his child $5,000 to buy a car and charged him 4% interest. Now I'm looking down here at the problem. I think they did this over 10 years, so you might want to change your notes on that. The amount the child will pay back is according to the formula. So P is the amount they would have to pay back. P naught is the principal, so that's the amount borrowed. And then this portion right here represents the interest. And you've probably seen that before, where to calculate the interest, you do the principal times the rate times the time, and the time has to be in years. When you do your rate, usually it's given as a percentage, but then you would change that to a decimal. So for this example, if it was 10 years, the amount the child would pay back would be the $5,000 of the purchase price of the car. That would be difficult to find a car nowadays that would cost $5,000 even for a used car. So plus they would have to pay the interest, which is again the principal, the $5,000, times the rate expressed as a decimal, times the time if it was 10 years. So hopefully they could do it faster than that. So they would have to pay back $7,000, and $2,000 of that would be interest. So that's simple interest. So for this, compound interest is usually the way that banks would give interest. So compound interest means that you are earning interest on your interest. So for example, if you put $5,000 in the bank at 4% interest compounded annually, we're going to determine the amount of interest for each year. So in the first year, you would earn your principal times your rate times the time, but the time is 1 year because we're talking about per 1 year, so that would be $200. So you would earn $200 interest in that year, assuming we're putting it in the bank. So now you have a new principal. So now you have $5,200 in the bank. So the second year, going into the second year, you now have a little bit more money in the bank. So you're going to earn interest on that. So we're going to multiply that by our rate. So that year, you're going to earn $208. So you're going to earn a little bit more. So now you have $5,408 in the bank. This is assuming you're not putting any more money in other than your initial $5,000 deposit. So now you have $5,400 or drawing any money out. So we're going to take that and multiply by 0.04. If you do that, you would get $216.32. And when you add those together, you would now have $5,624.32. So you would keep doing this. So now that's the amount you have in the bank. So I'm going to have you pause this and go ahead and fill that out. And then because you should be able to do that. So hopefully you did this on your own first. Last chance, because now I'm just going to kind of reveal all the chart. So I guess you can pause it and fix your answer or finish doing the chart. But I want you to notice after 10 years, this is the new principal. Okay, now I know the problem was borrowing money, the simple interest problem we did, but we could have just as easily have said simple interest invested, in which case after 10 years that investment would have been worth $7,000 at simple interest. So that you might not think that's a huge difference, but it is a difference of $401.21, because this you were earning interest on the interest as well as the principal every year. So when banks give compound interest, they compound with different time periods. So one very common compounding interest is quarterly. And what that would mean is instead of waiting every year to earn your interest, they add your interest in 4 times a year. So a lot of times, stock market investments or something like that, you might have quarterly earnings. So suppose you have $5,000 invested in a bank that gives 4% annual interest, but this time they're going to compound it quarterly, which means it's getting compounded 4 times a year. How much will the investor have at the end of a year? So even though the bank gives 4% interest a year, it's giving 1% interest every quarter of a year, because you're taking your interest, the annual interest, and you're dividing by how often during that year it's going to be compounded. So we're going to kind of go through a chart that would show that if you compounded quarterly. So for the first one, if you are earning just 1% interest in the first quarter, then you would earn $50. Okay, I don't know how all of a sudden I'm in red. Oh, because I guess I like blue better. It's probably easier to see anyway. So that would be $50. So you could just take your principal times 0.01 for the quarter. So your new principal would be $5,050. So then now that becomes your new principal going into the second quarter. And I kind of did this, well, actually, it's easy to see for 1% because you're moving the decimal point 2 places. So we get $50.50. So then that means we would have $5,100.50. So that's how much we have going into the third quarter. And then if you multiply this by 0.01, you get, and I'm rounding to the nearest cent, so we would have $51.01 interest. So now we would have 51.51 with 51 cents. So now that becomes the amount. And so now we would earn $51.52. And then at the end of that quarter, we would have $5,203.03. And no, I'm not doing this in my head and adding them up. I already had worked these out. So next, going into the next quarter, now we have this amount, and 1% of that would be this accrued interest. And we're going to continue this. I'm not going to pause it since there's not that many boxes left to fill in. So 52.55. So then that one would be 53.08. So now we have $5,360.69. So we would earn $53.61, and we would have $5,414.30. Now that's after, if it's 4 quarters in a year, so that's after 2 years. So compare this to our answer here after year 2, and you can see that when you compound quarterly, you actually end up with a little more money. I mean, we're not saying a significant amount, but the more frequently you compound, the more money that you will earn. So rather than completing a chart for longer periods of time, we can actually use a formula that represents exponential growth to find whatever that total investment would be. So R is typically the annual rate of interest, which is called the APR, and compounding gives interest over shorter periods of time. So again, we're going to take our value, or whatever the rate is, the APR, and divide by N, where N is the number of times per year that the interest is compounded. If T is the number of years that interest is given, then the number of compounding periods would be N times T. So, because if you're going to compound, if N is 4, because you're doing quarterly for 1 year, then 4 times 1 is 4. So, you're actually compounding 4 times. So, we're going to use this formula where we have this written like this. So, we have to get the amount, we're going to take the initial or the principal, and then this is going to represent the whole amount that you've put in the bank, 100%, plus we're going to take our rate divided by n, where n is the number of times that we're compounding, and then we're raising that to the nt power. So you have a list of all these things, what they represent. Biannual is rather rare. N would be 0.5, and you'd be earning interest every 2 years. Annual, n equals 1. Semi-annual would be twice a year. Quarterly, which is common, would be 4 times a year. Monthly, which is 12 times a year. Weekly, 52 times a year. Or daily, which would be interest every day, which is 365 times a year. And most banks do that. So if I invested $5,000 in a bank, giving 4% annual interest for 10 years, so kind of the same thing we did for the other examples, how much would I have according to the following compounding methods? So you don't necessarily have to set your calculators to 2 decimal places. You can just round your answers to that. So if it's biannually, n equals a half. I'm actually going to write the formula up here. So we have P equals, this is the formula from the previous page. So our P naught was $5,000 because that's what we're investing. Then we've got 1 plus, and it's R, which is 0.04 over N, and this is going to change. So this is the part that will change. And then we've got 10 years, so that's T. Remember, this is NT. So I'm going to call that 10N. So all these, the only variable we're going to have is where the N. So for biannually, you're going to have N as a half. So you can take your calculators and you're going to multiply 5,000. Let me grab my calculator down here. I'm not as happy with the calculator I kind of have to use now. Yeah, hold on. I'm going to pause this. Okay. So this, if you type this into your calculator, and I know you guys know how to do this, I'm just typing this in for n equals 1/2, which is the biannual. And so you can see my dollar amount is $7,346.64. That's how much you would have at the end of that 10-year period. So you can see, with that. Then next, I would do annually, where n is equal to 1. So let me go back to the other screen. Okay, so for the next one, we're going to let n equal 1. And if you do that, you just take the same formula. So we're going to put, instead of a 0.5 for n, we're putting a 1. Now, if you notice, when you're doing something like this on your calculator and you're repeating the exact same thing and all you're changing is one variable, then what you can do instead of doing the same problem multiple times is let's write this in our NY1, and then we can use our table and just plug in the values of n, except I'm going to use an x instead. So I'm going to type in, and so you should do this, 5,000. And then we have 1 plus, I'm going to do a fraction so it looks neat. So we have 0.04. And then we're going to put an x here. That's our variable. We're using x instead of an n. And then I'm going to raise that to the 10, because remember t is 10 for all these problems we're doing. And then I'm going to put my x. So I've got my equation written in there now. So if I go, I want to set my table. to ask so that I can plug in what I want to. So you set that to ask in auto. And now if you go to your table, you can type in, for example, 0.5. And you'll see our answer. Now you might notice, well, it's not to the nearest hundredth. Well, just go up so that you are over that answer and look down here and you'll see $7,346.64. And that's what you'd fill in for biannually. Then we just come back to our table and we type in a 1 for annually. And you'll see you can get your answer. And if you want to know the number of cents, then you can get that information as well. So next would be semi-annually, and then we want n to be equal to 2. So I'm going to let n equal 2. And you can get the value and fill that in. So go ahead and pause the video and finish this with your calculator to make sure you know how to do that, and use the values of n and just fill that in. Okay, so I put this screen up so it's your last chance to make sure you get them all done before I just reveal the answers. Hopefully you realized for hourly you have to take 365 times 24 to see how many compounding periods there would be. So you should have got these answers. And do notice that even though compounding more frequently does increase the amount of interest you're going to earn, but it does kind of at a decreasing amount, and it's not like a huge amount, but it is some. So moving on. The last thing I want to talk about is, you notice that as we were increasing it almost came to a point where it seemed like it was approaching some limiting value. And honestly, that kind of moves into a calculus question if we were to talk about that limiting value. And you could use calculus to show what it would mean to compound continuously. So as n gets larger, there's essentially no difference in the amount of interest you will gain. Some banks compound continuously, which means that rather than a particular time period passing and interest accumulating, money is just always gaining interest using this formula. So that we're using this value, this E, okay, so, and we've seen that before. We know that approximately 2.718281828, you have, it's, very similar. It's called a transcendental number. It's very similar to the idea like pi. You do have a button on your calculator, and so we can use that. So just to kind of show you how to use that, if you were going to take $5,000 invested at 4% APR compounded continuously, then what you would end up with is P equals $5,000, and then you would have E to the 0.04 T. And if T was for 10 years, so in 10 years, so we would have P equals 5,000 E to the 0.04 times 10. And if you evaluate that, you get $7,459.12. So notice that that's actually the same amount if you compound it every minute or you compound it every hour, because those were kind of approaching this value and this idea of compounding continuously. So that is it for this portion of the lesson. And then you have a homework problem where you have quite a few of these to fill out in a chart. So that's what you should be working on.